All right, let's go over talking about parallelograms with respect to vectors. It's not too hard, I don't think. I think it does require a lot more visualization, so that's the only hard part that I can really feel that if you're not, if it's you have a hard time with visualizing something, just draw it out. I think that's going to be the best way to go about this. Now, just a quick review about parallelograms, although obviously I think some of these are very intuitive. As you already know, the opposite sides are parallel, so therefore we have some relationship that looks like this. Although that's not really important to us this time around. Um, what we do care a little bit more about is the fact that opposite sides are congruent, meaning they are the same length. And not only so, but we also know that the diagonals of my parallelogram, so in this case AC, is actually going to bisect the other diagonal, so BD instead. So I know that BE is congruent to ED, and what is also true is that AE is congruent to EC because of the way BD bisects AC instead, right? So this is what's important in order for us to kind of like even begin thinking about like vectors and parallelograms. But you can think about this as like, okay, well, if you take a look, what you have is, am I missing a? Oh, I drew too many lines on one of these. But what you have here is really, and remember that like vectors are they're just kind of in space. Especially in this case, there's no defined, uh, coordinate plane or anything, and so um, the vector b is the same thing, which we can also call it AB in this case, is the same vector. It's actually also over here at DC, right? Because it's the same length and the same direction. It's just at a different position. But because there's no well-defined positions, it doesn't really matter. Same thing with vector A. DA is the same thing as CB. Again, for vector A, vector D, which is DE at the position DE, but it's also EB. And lastly, AE, which is C, vector C, is also EC. Okay, so when we look at some of these, um, we can kind of move these vectors around and kind of think about, okay, what kind of vector we have, what is the makeup of it. So for example, the vector AD is this guy here, right? AD is going to be, now A is the opposite, so therefore it must be negative A instead. So that's my vector AD, or negative A. DA is, as you can see positionally, this is the opposite of number one, but it's also, we can see on the graph itself, is just going to be vector A. AB is just B because, I mean, there's nothing else to it. You can see it from the picture. It's just the vector B. But again, you can just look at the letters. The letters have been switched, meaning the direction is the opposite direction. So I do have negative B instead for vector BA. All right, AE. AE is just exactly what vector C is, so no surprises there, I don't think. EC is also vector C because I can just pick this vector up and place it here. It'll give me the exact same vector. So this also vector C. While EC, of course, has to be the reverse, so negative vector C. DE is going to be vector D. Again, it's exactly what it looks, exactly what D is, so there's nothing to change there. But again, ED is the opposite of that, so negative D instead. EB, like we said before, it is actually the same length as DE, and so this is actually going to be the same as vector D as well. AC, now it's getting a little bit more complicated, but you'll see that AC, we said before that AE and EC is the same length, meaning this is just 2 times vector C. BD, very similar to the previous one, but you'll notice that D is in the opposite direction, right? So BD is actually 2 times negative D. Oops, negative 2D. CD is over here, and you can see that that's exactly the length of B, but in the opposite direction, Therefore, this is negative b. BC, very similar to the previous one, except now we're looking at vector A. This is negative A. And DC is the opposite of 13. Or you can just look at it as moving the vector B over. Now let's get a little bit more complicated. We have A plus B. Well, if you take a look at A plus B, I go from D. So this is A, but then vector B goes up this way, right? So we um, add our vectors by putting them head to tail. And our resulting vector, you can see, is over here. And what vector is that? That's 2 times the vector D. Okay, so I'm going to actually, now if you're I suck at drawing, so when I do this, it's going to look not very good. Okay, but this is A, and this is B, and this is our resulting vector, right? Which I know is 2 times the D vector. Okay, A minus D. Now, this is where I said, like, I really like thinking about this as the opposite, adding the opposite instead, because then I can kind of see better. Okay, like D. Okay, I need to add the opposite direction instead. Kind of see, okay, where am I going and whatnot. Okay, so A A is going to be directly horizontal this way, and opposite D, or negative D, will be this way, right? And so my resulting vector will look like this. And you can see on the, you can see that it is the diagonal, which is our C, but facing the other way, that means it's negative C. Okay, this is negative C, this is A, and this is negative D. Now, if you were doing this on the parallelogram itself, you have to know, okay, like, in order to kind of stay on the parallelogram, I would have to start here as A, and then negative D looks like this. So my negative C looks like that. Okay, negative B. Okay, let's start that off by drawing it diagonally this way. So this is negative B. Again, negative plus A or minus A is the same thing as adding a negative A. And so that's going to go the opposite direction, like so. This is negative A. I keep forgetting to put little arrows on my letters. And finally, this is my resulting vector. And of course, again, this is the diagonal, right? And this is going to be 2 times, oops, that value. Okay, C plus D. C is my diagonal, like so. D goes this way. And so my resulting is this side, which is B. Okay, again, B minus D. Again, I like to just think of this as adding a negative because I can just think about, okay, I'm going the opposite direction for D instead. So B is going up this way. Negative D goes downwards. And so my resulting is this diagonal here, which is C. Okay, we'll do a couple more here, and then we'll call it a day. All right, so very similar. Let me see. This is the same parallelogram. That's fine. That's fine. A plus B. We have, this is the same thing as earlier, but that's fine. A, once again, is over here. B, like so. So once again, this is the resulting vector, which I know is 2 times my D value. Okay, D plus C. D looks like this. C goes up to the right. My resulting is this side, which is the B value, B vector. Now, I do believe there's a mistake in this one. This should be minus instead. Or I guess I can just do add a negative. So the D vector is like so, while my A is here, or negative A, rather. The resultant is here. So this is actually my C vector. Now again, like this one is a little bit trickier if you're trying to do this on the parallelogram, right? Because to stay on the parallelogram, you have to start here as your D, A, and so your resulting is C. C minus B, once again, I do like to think of this as adding a negative instead. So add a negative. And so C is like so. My B goes down instead for negative B. All right, so this is negative B. This is my C. The resultant is this way, which is my D. Right, again, this one you do have to start on this side for your C, then go down for your B, and the resulting is your negative D. Negative D. Okay, C plus D. I'm going to go diagonally up for C. Then I'm going to go to the right. To the left. Ooh, like so for D. And this is going to result in B. And again, like my drawing skills are obviously quite bad, but it's just to help guide me. Like, okay, generally speaking, where am I going, right? To see, okay, what should it probably look like on the triangle itself. 2C looks like this. So let's see. C. Ooh, what in the world was that? Right, and so the resultant is here. That's not quite matching up, but that's okay. Again, on the triangle, this would be like this. Or I'm sorry, the parallelogram. A and then 2C is right here. So your resultant is this guy, which is B. 2D minus A, once again, I'm going to first change this to adding a negative. Actually, I'm going to change that right now too, just because that way I don't think about it later. 2D gives me one diagonal, two diagonals. I guess it's the same diagonal, but I'm sorry, the length in terms of that. And then negative A goes this way. This is D, this is D. So my resulting vector looks like this, which is B. Last but not least for these two that are three things, which really I've been kind of drawing my two whatevers, my scalar of 2 times a vector as kind of like three things anyway, because I'm drawing it separately. I have A, I got B, and then I have negative D. Right, it is negative D. And so now you do have to be careful because the resultant vector is going to look kind of weird, but it is going to be this guy, the purple, and it's like head to head because this is my starting point, and my ending point is over here, right? So this is just D. So it's kind of a long roundabout way to get to D. And then D plus C plus A, I D plus C. Ooh, okay. And A all the way over here. All right, and so my results in this time is going to be 1D, 2D. So it's actually 2D. Okay. Kind of, I feel like that's plenty of examples. If you want to do 18 and you want to ask me questions about that, that's perfectly fine. I'm just feeling a little bit lazy after so many examples of adding and subtracting. It should be very, very similar to what we did before as well. So let me know if you have any questions. I'd be happy to answer any questions you might have. Thank you for watching.